Push that rock with some math. This lesson is about the dot product of vectors. Here we go. Let's look at two vectors in two space. We have vector W and we have vector V. So here's vector W. It looks a little suspicious, that root 2 and root 2. I'm going to factor out a 2. Why would I factor out a 2? That seems weird. You don't see any 2's. Yeah, but you'll see why. Factoring is dividing. So when you factor out a 2, that means you divide by 2. So I divide both components by 2. And now I see a unit circle vector. This is a unit circle vector at 45 degrees, or pi/4 radians. This is a vector on the unit circle, and it's been scaled up by 2. Let's see, it would be about right there. Let's see, it looks like this. This is pi/4 radians, or 45 degrees. The radius, or the magnitude of the vector, the distance from the origin to the vector, is 2 units. Because it was a unit circle vector, they got doubled in length by that scalar multiplier. Let's look at the other vector now, V. So this also looks suspicious. See the root 3? Suspicious. Let's factor out a 4. Why would I factor out a 4? Well, factoring out a 4 is the same as dividing. And 2 divided by 4 is 1/2. And 2 root 3's divided by 4 is root 3/2. And this one is negative because a negative divided by a positive is a negative. Oh look, this is another unit circle vector. I mean, not all vectors just happen to be convenient unit circle vectors. But all vectors can be a multiple of a unit circle vector, just not necessarily a convenient one like this that's sitting at 150 degrees and pi/6 radians. Let's see, it would be something like this, to the left root 3, the 2 root 3's and up 2. And so it looks like this. And this angle here is 150 degrees, or 5/6 radians. Okay, now what we want to do, now that we have a nice picture of what's going on, the two vectors at hand, is we want to learn about the dot product of the vectors. We denote dot product with the super large, bold, mid-script dot like this. It's different from the regular dot that just means multiplication of two numbers. Here we have a number times a number. That's multiplication dot. This is dot product dot. Now, there's two definitions for the dot product. I have them both here. I don't have the definition here, but I'm about to demonstrate the definition on the left, and then this is the second definition on the right. The first definition says, so we're going to do the first definition. It says multiply the first components, so I get -2 root 6, and add to the product of the second component, so I get 2 root 2. Let's see, I could factor out a 2 if I wanted to and get -√6 plus root 2. This is not necessary, but you'll see why I want to do this in a minute. And I'll turn that around, so I have 2 times root 2 minus root 6. And that's how you get the dot product using the first definition. Now there's another definition. You can also define the dot product as the magnitude of first vector times the magnitude of the second vector times cosine of the angle between them. Well, this is a number, this is a number, this is a number, so this is going to be a number. Oh yeah, this is a number. So we see that the dot product takes two vectors and maps them to a number. So let's get this number. Well, the magnitude of V is 4. That's this radius here. It's 4. It's because there was a unit circle vector about right there that's been multiplied by 4, so it's 4 times longer than it was when it was on the unit circle, so the magnitude is 4. By the same argument, the magnitude of this vector here is 2. It's 2. So I have times 2. And then it's times cos of the angle between them. Well, in this particular case, we can see the angle between them. This is 150 degrees. This angle here is 45, so the angle between must be 105. This angle in between must be 105 degrees. So we have 105 degrees here. Now, this is not a convenient angle on the unit circle. So how are we going to find cosine of 105 degrees? Well, we'll use the sum identity for cosine. We'll say 105 is the same thing as 45 plus 60. Use the sum identity, simplify, and this is what cosine of 105 degrees is. So it's 8 times root 2 minus root 6 all over 4. But that simplifies, because 4 goes into 8 twice, to 2 times root 2 minus root 6, which is what we got using the first definition. So we see that both definitions, of course, give us the same number. Now, what's useful about this is we frequently do not know the angle between two vectors, but we can easily compute their magnitudes. We can easily compute the dot product using this definition when you just take entry 1 times entry 2 plus, first entry of the first one times first entry of the second one plus second entry of the first one times second entry of the second one. And you get a number, and then you can solve for cosine of the angle between them. That's why the dot product is so useful. Success starts here at Temple College.